All right, this is going on page 41 when we're done. Now, long division is a have to know because it will work for dividing all of the polynomials that we need. Synthetic division is a shortcut, and it does not work for everything. So it's nice to know, and it is a good, handy little tool if you can remember how to set it up right. That's the key. I had a lot of people ask me yesterday, isn't there another way to do it? I'm like, yeah, it's synthetic division. We're going to talk about it tomorrow. And then they're like, oh, yeah, but I always forget how to start that. So, I mean, yeah, it's easy if you know how to start it. But the other thing is, I also had somebody yesterday say, with the long division. So this is another one of those things that I just don't get, but I'm going to go with it. And I said, what do you mean? You don't understand like what we're doing? And he said, no, I understand how to do it. I don't understand why it works. And I said, well, yeah, I see what you mean there. Same thing with synthetic division. But last year somebody asked me that same question. And so I showed the classes like why synthetic division works. And, of course, you know, some people were following along, so you don't have to recreate it. Just make sure that what I'm doing makes sense. And then some people, it didn't make any sense at all to. But then I noticed some people were trying to do what I did in that and apply it to other things that really had nothing to do with synthetic division either, but it was like a weird kind of factoring. So I feel like showing that did more harm than good. I am a big fan of making sure you understand where stuff comes from and why, because I think it sticks with you a little bit better. But in these cases, it may be good for you, but it may totally confuse you. So I think what I'll do is I'll find videos of somebody else explaining it and put those in the playlist. So if you really want to see why it works, you can see that. But I don't want you trying to redo those processes because it's not going to, it's a weird thing you have to do to show that it works. And I don't want it to confuse you. So I'm not going to show you, even though I always like to do that. All right, so synthetic division. Synthetic division is what we're doing today. Shortcut to divide polynomials. Here's the super important part. This method only works when dividing by a binomial with a coefficient of 1. Okay? That does not mean that the polynomial itself has to have a coefficient of 1. It means that the divisor has to have a coefficient of 1. All right? So let's look at number 12. We've got this polynomial divided by this binomial, right? And so since I'm dividing by this could possibly be one of the factors. So if I have x plus 4 and I solve this, I get x equals negative 4. I want you to be writing that because this is, yes ma'am. Someone's at the door. Oh. Okay, so when we're going to look at some things where sometimes we're given the x equals negative 4 and we're doing synthetic division, and then I think there's some confusion sometimes on when you change the sign and when you don't. Well, you're not changing the sign. It's that you're solving it. So if x equals negative 4, then a factor is x plus 4. Like these two are related. We need to make sure we understand that. Okay? Put that away. All right, so now I'm going to have this negative 4, whatever my x value is, out here. I'm going to put in this little bracket thing. And then I'll also have, well, I'll put that at the end so I know how far to do it. The first row in here is going to be the coefficients of this polynomial. So that's 1 and negative 1, negative 27, and negative 28. And then down here, put another little box because that's where your remainder goes. Okay? I'm sorry. All right, so now we take this first term here and we just bring it straight down. It's a 1. Then you take the number that's on the outside, this negative 4, multiply it by this one. That gives you negative 4. Put it right there. Then you combine vertically. So these two together give me a negative 5. Then I do that again. Negative 4 times negative 5 gives me a positive 20. Then I combine vertically. Get negative 7. Negative 4 times negative 7 is a positive 28. When I combine these, I get 0. Now, your remainder will not always be 0, but if your remainder is 0, what that tells you is that this is a factor of that polynomial. So now to write my answer, because all it said was to divide, then I have these three right here are the coefficients of my answer. I just divided a cubic by a linear, which is going to leave me with a quadratic. Make sense? If I have three terms down here, it's a quadratic. One or more of them could be a 0, but I have 3 terms, which means it's a quadratic, and these are the coefficients. So I get x squared minus 5x minus 7. And if you multiply this back with x plus 4, you will get your original polynomial back. And it's quicker than long division, but again, and it's the process isn't complicated or confusing. It's just very different. So sometimes people get confused as to where to put what and whatnot. What questions do you have right now? Anything? You add them, yes. Notice that there is no just manual changing of signs like we did with long division. And the reason we were doing that is because we were subtracting. But since we're adding here, you don't actually change a sign. It is what it is, okay? What else? Anything else? All right, let's jump to number 15. What to do with non-zero remainders. So here I have x minus 3. So we're going to put x equals 3. 3 goes out here. Then I have 4, negative 16, 20, and negative 16. Okay. We all good? No? Everybody understanding where everything comes from? Okay. All right, so then we bring down the 4. 3 times 4 is 12. We combine, so then we get a negative 4. 3 times negative 4 is negative 12. We combine, get a positive 8. 3 times 8 is 24. We combine, and we get 8 there as well as a remainder. Okay. 3 terms down here tells me that it's a quadratic for my answer. So I have 4x squared minus 4x plus 8 plus my remainder. Do I just do plus 8? No, I have to do plus 8 over what? X minus 3. Good job. It's all coming back to you now, right? Right, exactly. So this tells you this isn't a factor. Like we can divide and we get an answer and it's something we can do if we need it, but it's not actually a factor. No, because our remainder isn't 0. Yeah. Okay. We good? All right. Now let's look at 16. So just like with long division, the missing powers can make things really yucky for you. With long division, usually you catch yourself because it's weird and like it doesn't work out. You don't always catch yourself on here because you can finish with the numbers because you don't even know what exponents they're going with. So be very careful. Every single exponent has to be accounted for. So this x plus 8 means x equals negative 8. So negative 8 goes on the outside. Then this is a cubic. So I have 1 for the x cubed. There is not an x squared term, so I have to put a 0 there. And then I have minus 49 for the x, and then a positive 120. And the constant term, that counts as one of your terms also. I'd have to put a 0 at the end if I didn't have one, okay? And then you could have more than one missing term also, so make sure you're paying attention to that. All right, so then we just solve this like the rest, bring the 1 down. 1 times negative 8 is negative 8. This is negative 8. Positive 64 and negative 49, what does that give me? 15. Negative 8 times 15, negative 120. So we get, this is 3, which means it's a squared, so x squared minus 8x plus 15. All right, everybody good? All right, you do 17. Then it's just wrong. Yeah, because they have to actually put none. Otherwise, yeah. How many missing factors do we have? 2. There are 2. Okay, so did we all get this far? See how we have 4 numbers down there? I mean, the zeros count as numbers. 4 of them, that means it's an x cubed. So this is the coefficient for x cubed. There's not an x squared, not an x, and not a constant, just a remainder. So we'd have plus negative 1 over what? x minus 9. There you go. Okay, we good? Awesome. Careful with those missing factors. All right, flip it over. So this is basically just telling us that if we have a linear factor, then we can use the division to start the factoring process for us, because if you look at this cubic right here, our only option to factor it would be grouping, and if I do grouping, I'm not going to get anything that groups that works for me. So, I mean, grouping doesn't work on everything. So when it doesn't, and I have a factor, then I can use division in order to get it down to maybe something I can actually factor. So since x minus 4 is a factor, then that means x equals 4. So we'll go ahead and do our synthetic division on here. 4 on the outside. Then I don't have any missing terms, so 1, negative 5, 2, and 8. Bring the 1 down. No giving up. And when you are told that you have a factor, your remainder should be 0. If you get something other than 0, you did something wrong, okay? So that's pretty much a giveaway there. So what we have here then, this gives me x squared minus x minus 2. Do we agree with that? So what we've just done is we have factored this one step. We've taken that first one, which is x minus 4, and I multiply it by x squared minus x minus 2, and then I would get my original one back. Okay? But it's not factored all the way. Now, do I have something that I can actually factor? Yes, I do. So I'm going to rewrite that x minus 4. We cannot lose it. This is going to factor into two binomials, x and x. The signs are opposite because that's negative. And what are my two numbers? Good. Negative 2 and positive 1. So this is your fully factored form that I want to see. Then this goes on to say factor it and then determine the zeros of the function. So what is the smallest 0 here? Negative 1, then 2, then 4. All right. Everybody okay with that? Any questions at all? When's lunch? All right, let's do number 19. So 19, I've got, and it says it's the same directions to divide. It says divide using long division or synthetic division, and then write it in factored form, then find the zeros. All right, so am I allowed to use synthetic division for this? Yes. So I get x equals negative 3. So negative 3. And then 3, 2, 1, 0. Okay, so I don't have anything missing. I'll let you get through the division part of it. All right. So do you agree with me so far? Yes. Any questions at this point? All right. So then you go ahead and factor that second part so it can get completely factored. And then I want to talk to you about that factoring a little bit. So you can do your grouping or divide and slide or whatever your thing is. Okay, so I want to talk to you about this fact. We all know how to factor. Some of us are a lot better at it than others, and that's all okay. We're all in our own places here. But some of you, if you're really good at the factoring and you can go through this stuff pretty quickly and the numbers make sense to you, do any of you factor something like that without using the divide and slide or grouping? Like just by looking at it? Okay, because the way I was taught is pretty much guess and check, and like you just have to look at it and figure it out. So those little shortcuts, like that stuff doesn't happen. So I just want to show you a thought process. Not all of you want to go down this road just yet, and that's okay. Here's some things that we know, and here's why it's important to know those things. If A is not 1, and it's a prime number, then it makes it easier. Because if it's a prime number like 2, then I know one of these has to be 2x and one of them has to be x. If it was a number like 6, then I could have 6 and 1 or 2 and 3. Like I have more options, so it makes it a little bit more complicated. Then I know since this is negative, the signs have to be opposite. So one of these is positive and one of them is negative, but I don't get to put it in there just yet because I'm not sure which one it's going to go with. Then these two numbers that go in here have to multiply to give me 5. Well, 5 is a prime number, so that's easy. It has to be 1 and 5, right? And then they're going to have to combine to give me 9. Well, if I put 5 here and 1 here, let me just go ahead and do that and then I'll take them out. 5 here and 1 here, then and I'm just kind of like thinking that. When I do 2 times 1, that's 2, and then 5 times x, that's 5. So the 5 and 1 there, that's going to give me 7. I don't want that. Plus they have to subtract. So clearly, it's going to have to be the 5 here and the 1 here. And I want a negative 9. So this 2 times 5 gives me 10, and this gives me 1. When I subtract them, I get 9, but I want a negative 9, so this is negative, this is positive. And the more you think about it, the quicker that whole thought process goes. I mean, I know it's kind of sounded like a lot, but you think through those things pretty quickly. And then you'll learn, especially with the smaller, easier ones, that sometimes you can just see them that way. And the more you try to do that, the more all of this makes sense. And you can just get through them quicker, okay? But then always check, 2 times x is 2x squared, 1 times negative 5 is negative 5, and then you get positive 1 and negative 10, okay? So there's that. Then x equals, what's your smallest? Negative 3, then negative 1/2, then 5, okay? All right. So then let's look at 20. Am I allowed to use synthetic division on 20? Oh. No. This is a binomial, but this is not 1. Okay? That's why. So instead, what's our other option? Long division. So I got 2x plus 5 out here. Good old long division. 6x cubed plus x squared. So I'll let you get through the long division. Make sure we can remember how to do what we did yesterday. When you go to factor this, if you feel like you're strong in factoring, see if you can do it with reasoning instead of like grouping or whatever else. If you're not ready for that, you know whether or not you're ready for that, and that's okay. And I'm never going to make you do it that way. It's just something that can help you in the long run. Okay, so let me talk you through this reasoning part of this again. This 3x squared, that means I know that one of them has to be 3x and one of them has to be x. Since this is positive, the two signs have to be the same, and since this is negative, they both have to be minus, so I can go ahead and put those in there. Now, this is not a prime number, so my choices are 1 and 4 or 2 and 2. So you want to kind of think through them. If I put 2 and 2 here, I'd have 2 times 3, which is 6, and then another 2, that's 8, that's not 7. So it's going to have to be 1 and 4. If I put 4 here, that's going to give me 12. I know I don't want that. So this would have to be 1, and this would have to be 4. So that I get 4x and 3x, which gives me that 7x, and they're both negative. And then negative 4 times negative 1 gives me the 4. Okay? So it's just kind of a reasoning process through it. It's not necessarily guess and check, but, you know, you just have to kind of think about what numbers work. All right, so then what would our smallest x value be? Negative 5 over 2. And then 1, and then 4/3. Okay, good. All right, so let's look at 21. Can we do synthetic division with 21? Yes, we can. So x equals 1. Put 1 out here. And then I get a 2, 1, negative 11, negative 4, and 12. Bring down the 2, 2, 3. Oh, excuse me. I have a lot of self-control. Know that we're supposed to get 0, right, because it is a factor. Now, we have 4 numbers down here. That means that function is going to be a what, that part? Cubic. So we have this x minus 1 times 2x cubed plus 3x squared minus 8x minus 12. Then we need to factor that cubic. What kind of process would we do there? Grouping. So go ahead and use your grouping and factor that the cubic. Do the thing. Do what you know you're supposed to do. When you're done with your factoring, notice that this was a quartic, so make sure you have 4 down here and that you didn't lose 1 along the way, okay? Everybody okay with all that? And factor that? Awesome. So then our x's, what's this? Okay, so when we do our x's, because this has come up a few times also, we can use this, we can do plus or minus 2 for these two. So does it go first or does it go last? Like where does it go? It's hard to say when we go least to greatest, so it doesn't matter. I'll put the plus or minus 2 first, take care of those two, and then I'd have a negative 3 halves and then a positive 1. Like if you want to separate them, it's fine. But we're going to have some where you literally have a ton you're writing out, so you're going to want to do them in plus or minus at that time, but I'm fine with you either way. All right, what questions do you have? Anything? Awesome.